final session will explore real-world examples of AI deployment that improve efficiency, optimize decision-making, and enhance service delivery. This discussion will highlight practical strategies for overcoming implementation challenges and also unlocking measurable value across industries. Please welcome the Vice President of Oracle Solution Center for Japan and Asia Pacific, Francis Han.
Thank you. Hi, everyone. Now, we have seen a lot of advancement in technology over the last several years. Advancements like democratization of data, as well as the code, and the language was much more advanced. And also you see that the AI model is moving towards autonomy, a lot more autonomy. And how this affects the enterprises across the industries. The enterprises have become smarter because the AI has been embedded into the applications, as well as the operations. They are also increasingly automated by AI. And also for the individual employees within the organization in the enterprises, they also leverage AI to improve or increase productivity. And as far as the consumers or end users of these enterprises are concerned, they benefit, through better services, faster response time, etc. Now, so let's look at why this is happening. For a long period of time, we have been seeing that the tasks out there, they are automated, right, by AI, and these tasks are mainly the repeatable, predictable tasks. Okay, and that has been there for a long time until sometime after 2012, 2013, you notice that face recognition, speech recognition, they have become more accurate, and that is because deep learning came to the scene around that time. And last few years, we saw this Gen AI exploded into the scene, right? And they are everywhere. And for this year and half of last year, you start to see agentic AI, right, taking shape. So this has, in terms of the task automation, it has moved from the predictable, area or territory towards the more unpredictable and non-repeatable tasks. Now this is say a language model which 4 or 5 years ago it does something like question and answer, which is something that can do a lot of things for individuals, for some enterprises, right, back then. But today it can do a lot more, right? It can take in input, any kind of input. It can be text, images, audio, video, right? And it can make inference of what this input is, right? And based on the inference, take action. Okay. So in this case, the image is about a man running with a gun. So the inference is to call the police, right? And then to come up with a script, and then convert the script to a text to speech, and then call the police. And in between, in this whole process, we can have a human to check on the script before it goes to the calling of the police. Or we could have a bot, right? We could have AI model doing the checking. And this brings this simple model towards autonomy. And in a typical agentic AI process, you would have multiple agents, each specialized in the subtasks, right? And all these agents work together as an agent team, right, to do the job. In this case, we have an agent team focus on this call center task, which is about taking in the audio input from a customer. So if the customer were to call the call center and give compliments, then there's not much we need to do. But usually it's about complaints, right? And if it's about complaint, then there are a few things that need to be done. One could be that you need to make sense of what's happening, what's in this complaint, and before you can do that, you need to transcribe speech to text, right? And if it's in a foreign language or language that you're not dealing with mainstream, you may have to translate this language to maybe English or Bahasa and so on. And there is also this similarity agent that takes in what the caller is saying and do a similarity check based on the past cases, right? So that we don't have to reinvent the wheel, right? In coming up with the resolution for the problem, you can dig out all the past resolutions, whatever information that has been there in the system, and then that could be this recommendation agent that recommends the next step, whether to escalate and whatever additional information required, etc. Now, so we have this agent team with a group of agents specialized in a subtask, doing each subtask on its own. But what's important is that for each of these agent, there's this resources behind the agent. Resources like database, documents, etc. And all these resources give the agent the memory, the knowledge, right, to deal with things so that they can be autonomous, right? So that's, very important for the this AI agent. Or it could be calling, services, right, behind the scene to get things done. So this is how it is, right? You recall this chart that I showed from machine learning to deep learning to Gen AI to agentic AI, right? Agentic AI is built around the Gen AI, like an onion, right? You have the layers that is created around the core, which is the language model, so that you can give it, the knowledge, the memory, etc., and empower it to do things, right? And to do things safely, right? With security, etc. So that's how you can see agentic AI, from this perspective. So there's this shift, given what I shared earlier. There's this shift from a reactive model to something that is more autonomous, right? We started with like what I mentioned earlier, a chatbot, right? A simple chatbot, do question answer, etc. And that progress towards something that can do a simple task, right? A simple AI agent, and then we progress to something more complex, right? And so and then the next level was is the fact that the AI agents can start to communicate, collaborate, right? So that together as agent teams, they can do something much bigger. So that's the journey of how we have progressed, right? From the process automation right in the beginning to this whole AI agent ecosystem, right? And coming from Oracle, we support our customers to build this AI agent ecosystem from this standpoint, which is unique in a way that it is not just across the department functions, the HR, the finance, the supply chain management, etc., right? Where we have the AI agents embedded in each of these functions, but also across the operations, right? across the operations of the enterprise, and also to help the individual employee with their productivity. So this whole framework is, designed to help enterprises to cover all these areas: the department functions, the operations, the individual employees. And this is done, through this embedded AI agents, right? That is embedded in the applications across the different functions. There is also the ability for enterprises to extend this AI agent, add on new agent, or make modification to each agent, or to create new agents on their own, right? Or you can bring external models into this whole ecosystem, so that the flexibility is there. So this is how it looks like in terms of the flow of things, as far as the agentic AI is concerned. Take for example a very simple transaction, converting from the purchase request to purchase order, PR to PO. Now, this simple process entails, some manual processes, a lot of checking, right? A lot of checkings, a lot of verifications, and once you create that the PO template, you need to populate with the right information, and then you flow that through some stakeholders to approve, right? Then when it's approved, then you need to notify the relevant stakeholders and so on, right? So it's very manual and can be quite painful. So that was just one task, right? In the near future, humans could be working with agent teams like this, like what you saw, right? And not just for one simple transaction, but many transactions. And it may not be just for applications for the enterprise, it may be for the operations as well, and maybe for something else, right? So that's how it may look like, right? And so I mentioned about the ecosystem that we support coming from Oracle. It cuts across a few key areas. One is the application layer, where we have the AI agents embedded into this layer. The second is this whole platform around the databases, right? Autonomous database, the 23 AI database, which is supporting all the different data types: structured, non-structured, vector database. And that's important because when you need to look for similar content, right, you need that kind of database to help you. And as well as the Oracle Cloud Infrastructure supporting this whole framework of the agentic AI ecosystem, and together with the best of breed models that we support, or our customers can bring in their own models as well. And this is how we can see it, from this whole perspective: the AI stack from Oracle, going from the infrastructure to the platform, where users can build their own AI agents, right, or the AI solutions using this platform, or to tap into the pre-built models, pre-trained models in AI services, as well as the applications layer that is embedded with AI. So the different flavors of AI that is working with the Oracle stack. So we have not just the AI agents, but the generative AI, as well as the classic AI. Now, agentic AI is here today, but in order to solve all the problems out there, you need a combination of these different pillars of AI, right? I'll go into a bit into this in the use cases. So this is one example of, let's say, for supply chain management. This is how it looks like in terms of all the different AI agents and models supporting this whole SCM, or supply chain management flow. Okay. Now let me go into the use cases now, just to talk about some of the things that we need the various pillars of AI to come together, right, to solve certain problems. I'll start with this crowd monitoring, right, where we have, let's say, there's the need to monitor crowd, right, at a certain area. So in this case, the Shibuya, this cross junction or scramble junction. So here, we have an AI model that is running close to this junction in an edge, right, at the edge, right, in this edge computing device. So the reason why you want to do that is because you want to have real-time response. Apart from crowd monitoring, which is a simple example, I've talked to different customers about the importance of real-time AI. One of which is coming from a prisons officer. So this prisons officer was telling me that they monitor fights in the prison cells. Now they already have an AI model or the computer vision tracking what the prisoners are doing, and when they are fighting, they'll dispatch officers to the scene, right? But because this AI model is running at the distance away from the prison cells, so that means that the response time is longer. By the time the officers come to the scene is usually quite late, right? So that's one case of this real-time AI. The other one was a car manufacturer. So one of the use cases within this car manufacturing process is that they spray paint the cars, right, in the factory. And because the AI model, again, it was running some distance away, the response time is there, right, because of latency. By the time they detect any problem with the spray nozzle whatsoever, right, and try to rectify the problem, it's too late. Too many cars painted badly, right? So that's another one of the many other reasons why real-time AI is important. So looking at this workload, real-time AI workload, there are certain things that need to happen or detected, rectified at the edge. There are certain things that can be done in the cloud. Some information can be passed to the cloud to analyze, process, etc. Like in this case, we can do crowd density analysis, right? And this is how it looks like in terms of the this edge computing device, which is deployed over here with the cameras. And this is a whole spectrum of the deployment options, right? From the cloud on the left all the way to the far edge. So the Ultra is smaller than a tissue box, which can carry in your backpack. And then we have the red device, which is on the top right, Ultra on the bottom right. And then on the left is this station where we can pack in all the computing capabilities in a container, self-contained with power, cooling, and everything, right? And it can be deployed anywhere, right? Or it can. So the other use case is profile search. For example, if let's say you have thousands of hours of CCTV footage, right? You can use natural language, right, to search for whatever contents you are looking for, right, in this video footage. So, for example, man pushing bicycle. So what happened is that this is tapping into the vector database, the AI model, etc., right, to pull out the relevant results, right, that matches the query. And the other use case is the car damage detection. So in this case, we have a customer who is deploying the AI, Oracle AI, to do this car damage detection. In fact, this can be applied to any assets, right? Any vehicles, any objects. So yet another one is safety, workplace safety, right? Use case where we can detect workers at height, they need to wear harness, etc. And then I'll skip this one, and maybe I'll just go with the last. So in this case, I pick up one video, which is coming from the Lima Langkawi, right, the aircraft area display, where we can do two things. We have two models running. One is the deep learning model doing the tracking identification of the aircraft, and the second model you can see is running the commentary at the bottom of the screen, right? So two models running in parallel, giving you this identification, tracking, and this commentary, right, in real time. So that's all I have. And this is the QR code in case you want to use OCI for free trial, right? So thanks everyone.